Welcome to section 4, and in this particular section we're going to take a look at some authentication basics and set this up in our application. And the learning goals for this is to implement basic authentication in our app and have an understanding of how we should store passwords in a database, how we can use inheritance in C#. And the reason for using inheritance is normally to avoid repeating yourself. When you hear the words DRY or the acronym DRY, this means do not repeat yourself. And there's certain techniques we can use in C# to help us avoid writing the same code over and over again. What we'll also take a look at in this section is how to use the C# debugger and how to go about getting information inside our code as the request is being processed and executed by our server. What we'll also introduce in this section is the concept of data transfer objects, what we want to send from our API down to our client, and also the other way around as well. We'll also introduce validation inside this section as well. And as part of the authentication, how are we going to authenticate the users to something like an API that we do not have a permanent connection with? Then we use something known as JSON Web Tokens, and we'll take a look at those in this section as well. On top of that, we're going to take a look at the concept of services in C# and also take a closer look at middleware inside here as well. And what we'll also take a look at in this section is extension methods. I said there's a couple of techniques in C# to avoid writing repetitive code, and whilst inheritance is one way, extension methods are another. So all of this is coming up in this section. But first of all, sometimes you might be thinking, I've got an idea for an application, but where do I actually start? Well, you typically start with the requirements. What should your application actually do? Now, we know we're building some sort of social dating app. And if you take a look at some typical requirements that would be involved in building an application of this nature, then a list of requirements might involve things like users should be able to log in, users should be able to register, users should be able to view other users, and users should be able to privately message other users. There's a certain word there that's used over and over and over again, and that's the concept of users. And this is where we start. We start with our user entity, and everything starts with the users in this kind of application, and then we build the rest of our app around this. So that's what we're going to start with, but what we'll take a look at next is what should we do with the passwords that the user uses to enter when they register or log in. And we'll take a look at that next. So what we're going to take a look at now is how we can go about storing something like a password in our database. Now, it goes without saying the worst thing that can happen to our application is that our database gets compromised in some way by some nasty hacker. And we need to consider that that's a possibility. So storing passwords in a database is kind of a big deal. How do we do it? Well, there's a few different options. Option 1, we could store the passwords in clear text, which is obviously a terrible idea, because if somebody does compromise your database and gets access to all of the usernames, email addresses, and passwords, then you've got a problem. And you then have to tell your users that, their passwords have been compromised and they have to change them. Now, whatever happens, you're always going to need to do that. But if you're storing your users' passwords in a database like this, then clearly that's going to be a problem. Now, a couple of our users in this database, you could say, well, they deserve to be hacked. And there are things you can do about that, which is to not let them use such a weak password in the first place. But commonly used passwords like that, there's not much you can do. If you do allow weak passwords and somebody uses a weak password and they get compromised, not your database, then that's really the user's fault. But we still shouldn't store the passwords in clear text. It's a bad idea, and we're not going to do that. So what we need to do is do something with a password. The user obviously enters their password in clear text. The password goes across the wire or the internet in clear text, but crucially, it's protected because we use SSL security to encrypt the data on the way from the client to the server. So we're fine with the users passing up their passwords to us in clear text. Now, option 2 is hashing the password, which means that we take their password, we add or apply a hashing algorithm to it, and we end up with a password hash. And we store the password hash in the database. Now, hashing is one way only. You cannot calculate from a hash what it was before it was hashed. So in theory, this is a pretty secure way of storing our passwords. But the problem with this particular method is that Bob and Tom have continued to use their weak password of let me in. But when we calculate the password hash, then the same algorithm is applied to the same password, which means we get the same result. Now, if our database gets compromised, then the attacker knows that Bob and Tom have got exactly the same password. And if he can somehow calculate the password from this, then he's got access to 2 accounts. It's very common for users to use the same password for different applications, no matter how much we're advised against it. And the problem with just hashing a password is that online there are dictionaries of every possible commonly used or combination of different passwords available, and their hashes have already been computed in various different algorithms. So what somebody would be able to do is simply take that password hash, paste it into one of these online dictionaries, and boom, they have your password within a couple of seconds. So this is also not a great way of storing a password. Simply hashing it is not good enough. When it comes to working out if the user's typed in the correct password, then we can simply calculate the password hash and compare it with the hash that we're storing in our database. And that's what we would do, but like I say, this is still not good enough. Option 3 is hashing and salting the password. Now, a password salt or a salt applied to a hashing algorithm is going to scramble the hash. So even though Bob and Tom have once again used the same weak password, notice that they now have completely different password hashes. There is no way for an attacker to know that Bob and Tom have got exactly the same password. Now, we're also going to store the password salt. Now, the password salt is another randomized string that we pass into the computed hash that then scrambles the hash in some way to make it very different to the original calculated hash, which is why Bob and Tom now have different password hashes. And then when it comes to working out if they've added the correct password when they log in, we simply need to calculate the password hash using both the password they've supplied and the password salt in order to calculate the scrambled with the salt password hash. Now, this is a better way of doing it, and for simple basic authentication, this is how we're going to implement it right now, because it's easy to implement, and 90% of the code that we write to do this is going to be fine for when we take a look at what we're going to do later on when we further secure the application. This is to show you the concepts of authentication, what we're going to do in this section. It's not going to be a battle-hardened, bulletproof solution, and you shouldn't expect it to be. This is one step above adding completely fake authentication. This gives you the concept of how authentication works in a very visible way that we code ourselves. And just to cover some frequently asked questions, why don't I use ASP.NET Identity? I will. It's coming later, and you will see how to use that, I promise. But ASP.NET Identity gives us all of the code that we can just use. It's magic, it's great, and it does a lot of the work for us. But it doesn't really show us how it works, and you end up with more questions about how does this work, how do I know this is secure, than if we do it this way. So we're going to implement some very quick and easy, simple authentication into our application to help us out. Which is why the second question, why are we storing the password salt in the database, is another one that I'm just going to answer with it's very easy to do, and it's not the way that we're going to finish up by the time that we complete this application. Because later on, as it says, we will refactor to use the widely used and battle-hardened ASP.NET Core Identity. ASP.NET Identity has been around for years, and it's commonly used in many, many applications. So it goes without saying that that's been tried and tested, and you can presume that's going to be secure. What we're doing now is kind of secure, but I wouldn't use it in a real-world application. And this is just a learning exercise to show us A, how authentication works, and B, so we have something to work with in our application as we build it. So that's the concepts of what we're about to do, and let's go ahead and now implement this. Okay, now we're going to implement the authentication, very basic authentication in our application. So what we'll do first of all is we'll open up our app user entity, and what we're going to do is add two properties to this. And they're both going to be byte arrays because this is what's going to get returned when we calculate the hash. So we're going to store this as byte arrays in our database. So the first property we're going to add is going to be the password hash, and the second one, again as a byte array, is going to be the password salt. And what we'll need to do to ensure these two additional properties get added to our table as columns, we need to add a new migration. So we'll just open up the terminal and we'll make sure our application is stopped. Remember, this is a required step before adding a migration. And what we'll do is we'll say .NET EF migrations add, and we'll just say user password added and press return. And this should work without any problems. And let's go take a look at what has been created. So inside our data folder, inside the migrations folder, let's take a look at the migration class. Now in our up method, we're creating our two columns, password hash, password salt. And notice that SQLite adds these as a type of blob. SQLite doesn't know what a byte array is. So the SQLite provider is going to translate this into something it does understand, and it does understand binary large objects. And what it will do when we get the data back out of this is it will pass it back into the format that we need, which is a byte array. So don't worry if the type is different to what you've added inside the C# class. All databases are different, they support different types, and SQLite just doesn't support the byte array type, but it will pass it back to us via the provider as a byte array. So don't worry if it looks different to what you've defined it as inside the class itself. So now we have our new columns. What we need to do now is update our database so this gets applied. So what we'll do is we'll say .NET EF database update and press return, and we can see what this has done. It's altered our table and it's basically added those two columns to our database. And if we go and take a look, and we'll say SQLite open database, and we select the datingapp.db, and we go to our solution explorer and take a look at the app, we can see that we now have the two additional columns inside here, which is what we're looking for. So what we'll look at next is creating a new controller to manage our login and register. So what we're going to take a look at in this particular lesson is the concept of DTOs, or data transfer objects. Now we already know we have an issue with our username and password. We need this to be an object in order to receive the properties in the body of our request. So that's one reason to use a DTO. Another reason to use a DTO would be, for example, our app user. When we return our app user, we're returning all of these properties when we return an app user to our client, including the password hash and the password salt. Now, I don't think anyone's going to suggest that that is a good idea. There's also several other good reasons for using DTOs as well. And as well as hiding certain properties from an entity that maps directly to our database, we can flatten objects if we've got nested objects inside our code. And also, when we look at relationships later on, then we could have circular references between an entity, another entity, that then has a relationship back to the original entity, and this can cause circular reference exceptions. So those are a few good reasons to be using DTOs in the first place, but the main reason we're going to use one first of all is for our account controller, so that we can receive these properties inside an object. So what we'll do in our API folder, we'll create a new folder and we'll simply call this DTOs. And inside here, we're going to create a new C# class and we're going to call this one register DTO and press return. Now, what this is going to take is just two very simple properties. It's going to take the string of the username and it's going to take the string of the password. Now, I mentioned previously how important it was for our app user to have a capital N for the username, but when it comes to our DTOs, it's not so important. We can map our username very easily into the app user entity's username without too much trouble. And like I said earlier, it's just a personal preference. I don't particularly like username being in camel case like this. I much prefer to have a lowercase n. It's a personal preference. You don't have to do it this way, but it's not going to cause us any problems to do it this way. So what we'll do now is we'll go back to our account controller, and instead of taking these two strings, what we'll do is we'll pass in our register DTO, and we'll need to bring this in from API DTOs, and we'll just call it register DTO. Now, of course, we need to update the properties for our app user. We're going to assign the register DTO.username to our username, and we'll pass in the register DTO.password to the password hash function where we're calculating the hash. Now, what we also want to do, we want our usernames to be unique in our database. We're going to use our username for many different things in our application, and we want to ensure uniqueness. So what we'll do inside this controller is we'll create a helper method, and we'll make it private, which means it's only going to be accessible inside this controller, and we'll make it an async task that's going to return a Boolean value. And we're going to call this user exists. And we're going to pass in the string of the username inside here. Now, what we want to do is see if there's already an entry in our database for a particular username. And if there is, we're going to return true from this. And if there is not, then we're simply going to return false. So what we'll do is we'll say return await and context.users, and then we'll say any async, and we'll need to bring something in for this, and we need to bring in Microsoft Entity Framework Core. And what we want to do is we want to pass this an expression to check to see if any username inside our table matches this username. So what we'll do is we'll use an expression and we'll say x.username is equal to username, and what we'll also do is make this username to lower, so we're always going to compare like for like. When we register a user, we're also going to convert their username, whatever they enter, into lowercase as well. So what we'll do, we'll head up to our register method, and before we do anything else, what we'll do is we'll check to see if we have a matching username in our database. So what we can do is say if, and then we can say await, and user exists, and then we can pass in our register DTO.username, and we can keep this all on one line. What we can do is make a statement. If we had multiple lines, we would need to do this and add some curly braces. But if we're doing something that's just going to return, or we only have a single statement, then what we can do is keep this all in line. And what we can do is say return, and we can say bad request, and then we can say username is taken. Now we get access to this particular property or this object simply because we're using an action result. And when we use an action result, we're able to return different HTTP status codes as a response to this. And one of them, which is appropriate to return for this, is a bad request, a 400 HTTP status to say that, yep, our username is taken. What we also want to do is make our username in lowercase. So our registered DTO will specify this to lower, and that way all of our usernames are going to be stored in lowercase, and we're going to check to see if it exists before we allow the user to sign up. So what we can do now is we can head back to Postman, and we've got our failing request here with our attempt to register Dave and password. But what we'll do now is we'll resend this request, and this time it should be successful. And we can see that Dave has been added to our database, and we're still sending back our password hash and salt, but we'll deal with that very shortly. And if I try and repeat this request, what I should find is that I get a 400 bad request and the username is taken. And that should apply whether I use Dave, or Dave with a capital D, or Dave in all capitals. Then all of these requests should fail, saying that the username is taken, and that's what we're looking for. What we'll take a look at next is we'll prevent this kind of behavior, because this with an empty username would technically be valid. And if I sent this, then oops, we now have a username that isn't really a username in our database. So we'll take a look at validation next to prevent that kind of behavior. So in this particular lesson, we're going to take a look at using the debugger, and because there's a small difference between the Windows version of VS Code and the Mac version of VS Code, I'm just going to demonstrate both on how to attach the debugger inside VS Code. So I've got my application started and we're using .NET Watch. That's fine. And what we want to do is we want to open up our API controller, the account controller in this case, and we want to stop execution in the register method. So what I'm going to do is I'm going to add a breakpoint just where we start the using var hmac method. So when we try and register a user, then we're going to hit this particular breakpoint. Now what we want to do to start the debugger is, if I take a look at my folders, inside the dating app we have two files inside here, inside .vs Code. We've got the launch.json and the tasks.json. Now if I go inside the launch.json, then we can see inside here we've got two options or two configurations, and these are for our debugger. So we can launch the debugger. If our application was not already starting, then we could use this option, which would then go ahead and start our application and attach the debugger to it. What we've also got is the ability to attach a debugger to an already running process. Now, oftentimes this is the easiest and quickest way to get the debugger up and running, so this is the way that I'd normally do it. And if you do not have the launch.json file and you don't have this option inside there, then what you can do is just double check what your shortcut keys are for showing all commands, and on Windows that's Control Shift and P, and you can search for generate, and if you search for .NET generate assets for build and debug, then you'll get the launch.json file created inside this folder. So I'm presuming you've got this available at this stage. What we do next is we go to the debugging tab in VS Code, and we use this drop down and we select .NET Core Attach, and it gets this configuration from that launch.json file. So we'll click on .NET Core Attach and then we press the play button to start debugging. But what we're looking for is the process that we want to attach to, and this is the one that often causes confusion between the Windows version and the Mac version, because they do appear slightly differently. And that's because of the way that Windows handles processes. It uses executables rather than DLLs, which is how the Mac version surfaces this process. So what we want to do is just look for API. And what we should find is that inside our file system, we've got the API.exe running. Our project's name is API, and inside Windows, then it's using a .executable as the process in this case. So what we can do is select this process, and this should go ahead and start our debugger and attach it to the executable there. And if we go to Postman and we click on register user and make sure we're using the one that's going to fail, which is the one with the body of the request, if I click on send, then what I'm going to do is hit my breakpoints, and I can see I've stopped the execution there. So this is as far as I'm going to go on Windows, because I'm way outside of my comfort zone, and I'm just going to run through how to use the Mac version of this. So I'll put a timestamp of where you can skip to if you're on Windows. So I'm just going to go and demonstrate how to do exactly the same thing on the Mac. So I'm just going to continue this demo on the Mac. I'm going to add the breakpoint as I did on the Windows computer, and I'm just going to make sure I've got the launch.json file along with the .NET Core attach option, which we're going to use to attach the debugger here. And I'm going to select the debugging tab, select the .NET Core attach, and then I'm going to click the play button. And as I mentioned, it's slightly easier to see it in the Mac version of this, but we do get a DLL instead of an executable that we're attaching to. And once again, we'll just search for API, which is not a good thing to search for in here because there's lots of different options. But what we're looking for is the API.dll, which is, in fact, if we search for API.dll, then we do get the list filtered down to just what we're looking for here. So I'm going to select this and start the debugger inside this version of VS Code. And once it's up and running, what we can do now is make the same request so that we hit our breakpoint. So I'm going to head back to Postman. And what we want to do is send this request, the one that failed before, so that we hit our breakpoint in Visual Studio Code. So I'm sending the request, I'm getting nothing back, and we hit the breakpoint inside here. So I'm just going to drop that down because I don't need to see that. And inside the debugger, we've got various options how we can inspect our code as we're going through the debugger. So we've got different options at the top. We've got an option to step over this method that's being executed. We can step inside, step into if we want to, and we can step out if we want to as well. Now, what we want to do is take a look at what's coming in as the parameters here. We've got two variables. We've got the string of the username and the string of the password. And if we hover the mouse over, then we can see that both of these options are null. Now, that's a clue to the problem that we're having here. We don't have the password or the username being found by our register method. And the reason for this is that when we do send something up in the body of a request, we have to send it up as an object. And this is not an object. This is two separate string properties or string variables that we're trying to access. And even though we're using that API controller attribute, it's not smart enough to take two separate string properties and map them into an object. So this is the reason we're failing, but it does give us an opportunity to take a look at the debugger and how we can use it. We can also see our variables populated over on the left hand side here. We're getting null for HMAC and null for user, but we would do at the moment because we haven't got to the point in the code where we execute this. So what we would typically do at this point is we would step over our code to see what's going on. We already know why we're going to fail, but when we do fail, what we'll find is that we fail at this point. This is the point that gives us a problem. Now, if we know our password is null and our username is null, then which part of this does give us a problem? It's not going to be the username because it's no problem to set our username property as part of our app user to null because a string can be null. It's fine. Where we do get the problem is in this part where we're trying to create our password hash. What we're doing here is using this compute hash method, which is expecting a byte array. In order to get the byte array, we need to execute another method called getBytes, and it's at this point it runs into an exception because getBytes is expecting something to convert into a byte array, but it can't convert null into a byte array, and that's where we face the problem. So if we just step over again, we'll immediately find that we leave this request because we hit an exception. And if we go back to Postman, we'll see that we've now got the same exception that we see inside here. And we can see where we failed. We failed on our account controller at line 23. And if we go back and take a look at our account controller, well, it's where we're trying to create a new user in this case. So that's just a very brief look at using the debugger. It can be a useful tool to help you understand what's going wrong inside a method. And it gives you an opportunity to inspect what the value is of variables as you go throughout the method as well. And there will be opportunity for you to use this when you make a mistake in the code and you need to troubleshoot a problem. It's always a good idea just to practice using the debugger to see what's going on inside this. Obviously, this is for our C# code that we'd use this for. So we could use this button to detach the debugger. And what we'll take a look at next is how we can get the properties from the body of the request, because we don't really want to send up this information in a query string. It's better to use the body. Okay, what we're going to do now is create an account controller so we can register and log in our users. So what we'll do inside the API, inside the controllers folder, we'll create a new class and call this one account controller. And what we want to do is derive from the base API controller here. And what we'll also do is add a constructor so that we can inject our data context into this class. So we'll specify data context, call it context, and then we'll need to bring in the using API data, and then we can just initialize our field from parameter here. So now we've got our controller basically set up. And if we take a look at the base API controller, we're going to take a look at one of the functions of the API controller, what this attribute does for us. And if we look at the description here, it just says that controllers decorated with this attribute are configured with features and behavior targeted at improving the developer experience for building APIs. So this is for us, it's not for the end user. And one of the features that this does, we'll take a look at very shortly. But first of all, let's create the method that we need inside here to register a new user. So this is going to be a HTTP post, and we use post if we want to add a new resource through our API endpoint. And because we're creating a new user, then a HTTP post is the right method to use. So let's create the method itself. And this is going to be an asynchronous task because we're going to do something with our database here, and we're going to return an action result, which is the normal thing that we're going to return from any of our controller methods. And we'll take a look at what this does and what options this gives us as we use our controllers, but for now everything is just going to be returned as an action result, and we're going to specify the type of thing that we're returning. And in this case, it's going to be an app user. And we'll call a method register. And we'll need to bring in a few things here. So we're going to need to bring in system of running tasks. We'll need to bring in ASPNET Core MVC. And we'll also need to bring in API entities for our app user. Now, our register method is going to need some parameters that we're going to receive as part of the post request. When we send up an HTTP post, we can send up data in the body of the request, and it's going to be received by our API controller. Now, one of the things this API controller attribute does for us is it automatically binds to any parameters that it finds in the parameters of our method here. So we know, for instance, that when a user registers, we're going to want to get their string of their username and the string of their password. Now, if we didn't have that API controller attributes, then what we would need to do is add another attribute to the parameter here and tell it where we're getting the information from. And there's different options about where we can get data when it comes to an HTTP post request or any request. We can get it from the body of the request, or we can get it from a query string. But because we're using that API controller attribute, we don't actually need to specify any of these parameters here or these attributes. We can rely on the API controller being smart enough to figure out where these are coming from. And what we're going to do inside this method is, first of all, we're going to use a using statement inside here. And we're going to say using var hmac equals, and then we're going to say new hmac char 512. And this is going to provide us with our hashing algorithm that we're going to use to create a password hash. Now, this using statement we haven't used yet, but what this ensures is that when we're finished with this particular class, then it's going to be disposed of correctly. Now, anytime that we're using a class with the using statement, it's going to call a method inside this class called dispose, so that it disposes of this as it should do. Now, any class that uses the dispose method will implement something called the iDisposable interface. Now, this is a bit of a pain to demonstrate, but I'm going to do it anyway. And if we press F12 with our cursor inside the class itself, it's going to take us to the metadata about this class, what different methods it has inside it. And when we hover over something, this is what it uses to give us the description about what's happening and what this class actually does. So in this case, we can see that this inherits from a class called HMAC, and it has a default constructor with no parameters. It has a constructor that takes a key as byte array, and then it's got a property for the key. It's got another boolean there. Then we've got the initialize method, and this is what we're looking for in here. We've got a dispose method here. And what this does, it releases the unmanaged resources used by this class and optionally releases the managed resources. So it uses the dispose method. Now, any class that implements the iDisposable interface has to provide that method. And this is the bit where it's a bit of a pain, because we're going to go up through the inheritance chain to see where it's getting this from. So this class inherits from HMAC. We go up to HMAC, and then this class inherits from keyed hash algorithm. We go up to this class, and this class inherits from hash algorithm. And we can see that the hash algorithm class implements the iDisposable interface, and any classes that derive from this class will have to provide a dispose method. Now, if we loop back to our account controller, that's what we're doing with this using statement. We guarantee that as soon as we're finished with this class, it's disposed of correctly. So what we're going to do now is create a new user. So we're going to say var user equals new app user, and we're going to initialize this with some properties. We're going to give it a username and set this equal to the username that we're getting from our parameters. We're also going to create a password hash using the HMAC SHA-512 class. So we're going to say HMAC, and then we're going to say compute hash, and then we're going to say, and if we take a look at what this method requires, then it returns a byte array, and it takes a byte array as a parameter. Now, our password is a string, so we need to make this into a byte array, but our password hash is already a byte array, so we can just pass in the returned value of this into our password hash. But we need to get the hash of our password, and to do that we need to use encoding, which we get from system.text, and then UTF-8, and then we can say get bytes, and then we can pass in our password that we get from our parameters. And what we also need to do is generate the password salt. And if we take a look at HMAC SHA-512, this initializes a new instance of this class with a randomly generated key. And we're going to set the key for this class to our password salt. So we're going to say hmac.key. And then we finish this statement with a semicolon. What we'll do next is add our user. So we'll say context.users.add and then pass in our user. And all this is doing is saying to Entity Framework that we want to add this to our users collection or our users table, but we're using the add method here. And if we look at the description of this, it says it begins tracking the given entity and any other reachable entities that are not already being tracked. So we're not actually adding anything to the database here. All we're doing is tracking this now in Entity Framework. What we could do then is we can say await context and save changes async. And this part we do actually call our database, and we save our user into our users table. And then what we can do is say return user. So okay, great, we've now got our register method. What we'll do now is we'll go to Postman and test our register method. And let's go take a look. Now, if we take a look at the Postman collection here, we've got two different register user options. One of them is going to register the user using a query string, and the other one is going to register a user using the body of the request. So we've got our username Dave, password, and in the other one, the query string, we've got the username Sam and password equals password. Now, our API controller doesn't know where these values are coming from. It could be in the body, it could be in the query, but we're leaving it up to the API controller attribute to figure this out for us. So let's see what happens. Now, the first one we'll use is the register user, where we're sending up the username and password in the body of the request. Let's click send and see what happens. And we get a 500 internal server error. That didn't go very well. By the way, if you see a 404 not found here instead of this error, then what I'd suggest is you just come back to VS Code and stop your server and then restart it again. Sometimes .NET Watch doesn't always pick up when we've added a new controller. So do that please if you run into a 404 not found. And this request didn't work. Very disappointing, but I was expecting that. Let's try the next request. This one's going up on the query string with the username and password. So let's click send. And this time we get success. We get our username created and we get our password hash and salt coming back, and our SQLite database has generated a new ID. So what we'll take a look at next is why didn't this work, and what we'll do to help us understand what's going on is we'll make use of the debugger. So we'll introduce that next. Okay, so we want to create a new controller so that we can manage our user login and register. But if we take a look at what we currently have, we've got our users controller and we've got a weather forecast controller. Now, we don't care about the weather forecast controller. This will never form part of our application. But we do care about our users controller. We're going to be using this quite heavily. And we will be creating several more controllers in our API project. Now, every controller shares similar properties. They have this API controller attribute, they have a root property or attribute, and they always inherit from the controller base. Now, we might not be injecting the same things into every controller, so we can't really do much about this, but what we can do is create a base API controller that has all of these properties that will save us from repeating ourselves over and over again in each controller. So what we're talking about here is inheritance, and what we'll do is we'll create a new class called base API controller, and inside this class what we're going to have is the API controller and root attributes inside there. So we'll just add these to the top of this controller, and we'll need to bring in certain things, but we'll also be inheriting from the controller base, just as we did in our other controller. And we'll bring in using Microsoft ASPNET Core MVC, and that's all we need to add for this. So what we can do then is we can open up our users controller. And instead of deriving from controller base, what we're going to do now is derive from our base API controller. When we do that, we no longer need these two attributes because they're exactly the same as what we added to our base API controller. When we inherit from another C# class, we get all of its attributes, methods, and properties available in the class that derives from that particular class. So we no longer need these inside there. It doesn't save us that much typing in this example, but it is a powerful thing to do. And what we'll do is we'll head over to Postman to make sure we haven't actually broken anything. And what we'll do this time is we'll take advantage of Postman collections in this course. And what we can see here is we don't have any collections, but what I've provided for you is a Postman collection that has all of the API requests that we need to make for our application, and there's also some cool tricks in there that I want to show you as well. So what we want to do is click on Import and then go to the Student Assets folder, and inside here what we're looking for is the Dating App Postman Collection.json, and we're just going to drag that inside and confirm our import. So I'm just going to click on the Import button. And what we should find is that we've got all of our API requests for all of the different sections here. So if we look at section 2, then we've got a request here to go and get our users. And if we click on send, then we can see our API request is still working, but the API URL is pre-filled in this case. And if we click on get user and click send, then great, we can get an individual user as well. So this is just a convenience thing for yourself, but there are some cool tricks we can do with Postman. And by providing you with a collection this way, it will give me an opportunity to explain what those tricks are to help us quickly and easily test our API as we go along. What we're going to take a look at next is creating an account controller so that we can actually start to register and log in users. So what we're going to take a look at now is how we can use validation in our API to prevent this kind of behavior from happening in our registration. And what we'll do, we'll head back to VS Code to take care of this. Now, we could add validation at many different levels in our application. We can add it at the database level, we can add it at the entity level, but a good place to add validation is at the level of the DTO. This is the properties that we're getting in our account controller, and we want to validate what's inside here. We don't really want to validate against the app user because, well, we can't validate the password hash or password salt anyway. But in the DTO, these are the properties that we're actually receiving in the body of the request. And in our account controller, then our API controller is going to check this for us if we add validation, and it's going to send a response back automatically for us if the validation fails. This is another one of those tricks that, if I just go back to the base API controller, this is another feature of this API controller attribute. It automatically validates the parameters that we pass up to an API endpoint based on the validation that we set. So how do we actually validate something? Well, this is pretty simple to do as well. What we can use is something referred to as data annotations, and we can specify that these properties are required by adding the required word in square brackets, and then we just need to bring in system component model data annotations. So our username is required, and we also want to do the same for our password as well. Now, notice there's different options here. We can add regular expressions, we can add an email address, we can add a phone type of attribute to say that it should be a well-formed phone number. We have string length validations, and we can do all different types of validations as well. But if there's something that isn't accommodated by one of the out-of-the-box validators, then we can always use a regular expression if we needed to do so. I'm just going to keep things nice and simple at the moment, and we're just going to say that these two properties are required. Now, if we go back to Postman and we repeat this request, let's see what happens. So I'll click on send, and this time we get a response back saying that one or more validation errors has occurred. And the status code, the HTTP response code, is a 400. And then we get the errors in an object, and we get an array of the different errors that are returned when our DTO was validated. So if we take out the password as well and then click on send, then what we'll find is that we get both of the errors returned inside this errors object. So validation, nice and simple. We can go a lot further, and like I say, we could validate at the database level all the way through up to the DTO level. But the DTO is a good place to handle validation because of the API controller attribute, and how it automatically validates the parameters that we pass to an API endpoint. What we'll take a look at next is the login method, so that we can not only register users, but we can also log in, and we'll take a look at that next.